accidentally, why am I talking? I once accidentally left all of the math and science exams for an entire school on the stage gym at a band practice. Yeah, and then the janitor found them, and I was unpopular with my peers for a few days after that. They thought that was, luckily no, or at least not that we know of, but I'll tell you my students didn't, because that was a massacre, that chemistry exam. But this class will not be like that, I promise. Well, because that snake is very sinusoidal, don't you think? He's got like a lovely sine curve pattern to him. Yeah, did I say one again? See, this is why we can't have nice things, Joe. Okay, so today we're going to talk about taking those functions we looked at yesterday, these repeating sine and cosine functions, and transforming them. And I really do think, and I hope you're going to find this really straightforward, because this is our 4th time now looking at some functions and talking about transforming. And you're going to see it works exactly the way all the others are. Exact same thing. Right? Okay. So yeah, we'll get down to it. Shouldn't take long, and I'll give you your homework, and we can get out. Tomorrow we're going to be on the computers, and we're going to actually work with, we can work with modeling things with this. We're actually going to look at like some tidal data, like the tides from the East Coast, and learn how we model those. And yeah, like we talked about the lunar pattern yesterday, and how we can use sine wave functions to model these things. That's really kind of fun, interesting stuff. Okay, so and I think that's probably how scientists do it. When they have to make predictions, they just hire a guy to stare at something. They never like write it down and make an equation. So it's like you stare at this. I'd like that job.
Did you just say they do your job to watch
And then once we came up with some numbers to describe it, I stopped staring at them, which was the better part of that job, I can assure you. The bearded dragon observation portion of it, they're cute for like the first day, and you're like, oh, they're so cute. Look, it's climbing under the rock. Oh, look, it's going up under the heat lamp. Then by day 7, you're like, this is not pleasant. And then by day 30, you're like, I could have been a gas station instead I'm doing this. Anyway, enough about me. So the first thing I want to look at is a vertical stretch or a compression. Now, from every other transformation we've done, what letter do we use to vertically stretch or compress, and where do we put it? Yeah. That's right. Yeah. So we use the letter A. We typically talk about having an A value, and we put it right in the front of the equation. So here we have the original function, sine x, and we're going to plot 2 against it. One of them we're going to make the A value 2. The other one we're going to make the A value what? Don't leave me hanging, team. I can't be the only enthusiastic person in the room right now, can I? Maybe I am. 1/2, that's right. So let's take a look down here. In the original function, when x is 0, what's y? In the original f of x is sine x. At 0, what's the y value? 0. What about at 90? 1, very good. What about at 180? What about at 180? Let's take a look. Let's go to 180. What's the y value here? What's the y value here? It's not a trick question. 0, yeah, that's right. Right, it's just right on the x-axis there. And what about at 270? Where are we now? What's the y value here? This is 270 comma what? -1, that's right. You don't need to write this on here, by the way. I'm just showing it. Okay, and what about up at 360? Very good. And then, of course, after 360, what happens to this cycle? Sorry? Yeah, it does the same thing. It repeats. Because again, these are based on taking the sine of the x value. And we know that the sine of all angles after 360 are coterminal. They are the same as one of the angles between 0 and 360. Does that make sense? Tell me if it doesn't. I just say it doesn't. That was really folksy of me. Okay. Now, when we add that a value in front, does it change the x values or does it change the y values? If we put it way out in front. Change the input or does it change the output? Who remembers? It's been a while since we've done this. Is it going to move this thing up and down or is it going to move it left and right? Well, let's check. If we're not sure, let's go to Desmos. I should have kept this open, really. Hey, what am I going to have to make my x range for this function? What x values do I need to span? Hey, team, focus in. I'm making a graph here. Sine. What do the x values have to be if we're talking about a sine graph? Can I leave them negative 10 to 10? What am I going to get when I punch this in? F at x is equal to, do I have sine on here? I must somewhere. There we are. To sine x. Oh, I need to put it in degrees mode. What's the problem? Why am I seeing almost nothing here? What degree range does the sine function work in? Yeah, between 0 and 360. So my scale's just not very good. So I'm going to set the scale between like negative 961 and positive 1,000. There we go. Okay, so there's my sine function. Now, if I put an a value in front of it, we had a slider for that a, what's going to happen as I make this number bigger? If I make this number 2, what should happen? Yeah, exactly. It's precisely right. Isn't that lovely? So you say that sarcastically, but I mean it so seriously. Sorry? Okay. It's surprisingly difficult to get to land exactly where you want. So this changes the y values, right? So the x values don't change. This thing does not shift left or right, which means that our x values of interest are still going to be, well, that was fascinating, are still going to be 0, 90, 180, 270, and 360. But as I made that a value 2, what happened to all of the y values? Yeah, they got stretched. By how much? They all get multiplied by 2. They get twice as big. Time is just the original y value times 2. Does that make sense? That's our transformation. If a is equal to 2, a is out front of the whole thing. It's not in with the x, so it's affecting the output of the function. And it behaves exactly how we'd expect it. Well, what's 0 times 2? But what's 1 times 2? 2. 0 times 2 is? Negative 1 times 2 is? I think you do know. I'm going to throw my shoe at you. Correct. And 0 times 2 is? 0. Correct. All right, so let's take a moment and graph this. And I'm going to use orange because I like it. Sorry? Yeah. And what we should get is the exact same basic shape. And this is, oh boy, that was not good. Okay, I'm going to try really hard. I think I have to sit down for this. I don't know why I find drawing these so challenging, but I really do find them difficult. Let's try again. Well, surely you can do better than that, but that's the best I can do. Now, what if instead of using 2 as our A value, we had used 1/2? I want you to fill out that next one and draw that one on as well. You have colors too. That's great. If anyone wants colored highlighters or something, I do have a box in the back there. You can put your hand up on it. You okay?
No.
I'm sorry. I'm sorry you don't have that. I wish you would. I want you to do the same thing for h at x. And remember, h at x is not h at x equals 1/2. Oh, beautiful. Great. You got it. Great. Beautiful. No. No. Officially no. Extension towards what I'm about. Well, for this type of plug, for the type of plug that's not going to be back in the computer, back in numbers, something like that. It's really normally think you just use like extension code, but you'll think the other side on one side, as much as you want. This seems kind of complex. Like, why make this problem? Let's just try to make it out of it. I guess, yeah. Probably it's something with the board thing like 3 times. Sorry? I don't know if the problem in public education is we have too much money. Maybe.
I'm not saying there's too much money that's a lot of resources. I'm just saying there's too much money that's given.
Yeah, you might be right. Yeah, you might be right. Okay, so again, with an A value, does it change the value of x at all? So those x values are going to be the same. 0, 90, 180, 270, and 360. But the y values, what is happening to them here? Yeah, they're being cut in half. 1/2 of the original y value. This is too cumbersome to write with. Okay, so what is half of 0? 0. What do we put in this one? Yeah, 0.5. If you put 1/2, if you like the fraction better, nothing wrong with that. What goes here? I just got a nose crinkle at a fraction. I mentioned fractions and I saw. That could be called a sneer, I think, maybe. Yeah, this would be 0. Was that not a sneer? That's true. That was more sneer-like. Maybe a scowl? This one might have been a scowl. Distaste. Okay. What goes here? Great. And brace yourself. If you put -1/2, that's okay too. And in the last one? 0. Very good. So how would we graph that? Well, everything that had been a 1 this time would be 0.5. All the zeros are unchanged. I wish I'd shown less of this function. That's what I wish. There we go. Now you'd think the smaller one would be easier to graph. I always find it trickier, actually. Oh, I was doing so well. And I wasn't. I was doing well until I wasn't. That's gonna be the title of my autobiography. Joe Orlando, doing well right before he wasn't. It might be my last words. I was doing so well today, and then I wasn't. Okay. How's that? Does that make sense? I want to mention that just like any other function, we can flip the whole thing by making this negative. But in the case of a sine function, that becomes less important because it repeats. And we'll see that when we get to shifting it left and right. You never have to flip a sine function to model something. We never need to have a negative a value. And we'll talk about why that is. But we model very specific types of things with sine functions. And so yes, you can flip the whole thing by making it negative. In practice, if you're actually practically using these functions to model things, that's not a facility we use very often with these repeating functions, because they don't go forever up or forever down, right? They're constantly coming back and returning to themselves. They go forever left and right, but up and down, they're periodic. They make a wave. All right. Questions about that? Comments about that? The one thing I will say is if you want to find the amplitude of one of these functions, orange one here, what's its amplitude? What's the amplitude of this orange function here? Yeah. 2. Very good. What is the amplitude of the original function here? What's the amplitude of the original function f at x? 1 is correct. Also, we're going to do class in Spanish now, possibly Italian. And what is the amplitude of the purple function, h at x? That's right. All of which is to say, if we want to know the amplitude function of a sine wave, all we have to do is look at its a value. And it says that right on the page, so you don't even have to write anything. I was feeling generous. I regret it already. Sorry? Yeah, I feel like I'm facilitating laziness. Okay. The next thing I want to look at is, what if we, instead of multiplying or dividing the whole function, what if we add or subtract? What should that do? So, if instead of putting an a in front, what if we had value at the end? So what do you think? If we take the original function and just add k to the end, what's going to happen to this thing? What should it do? What do we think? I'm seeing some hands play the accordion. I saw somebody else being a metronome. Wasn't quite sure what this meant, but I liked it. I was hoping for a YMCA from the back. It didn't happen. That's okay. I forgive you this time. I hope that. See, that was good. Shall we? Well, let's say, first of all, this k, is it directly with the x? Are we affecting it, or is it affecting the function on the whole outside of the x? Yeah, to me, like, it's not in with the sign. It's not in with this equation here. It's out at the end, so it's affecting the whole thing. So is that affecting the input or the output? Well, which one's the input? The input is the letter x. And again, is this k right with the letter x? Is this the sign of x plus k? No, it's the sign of x Done, do that math, and then add k. So we're doing it after the function's been done. We're affecting the whole function, which means it should change the y's. It should change the outputs. Now, if we're adding and subtracting, will that stretch or will that shift? Yeah, it should shift the whole thing. So if I make this number 3, the whole thing should move up by 3. Not stretch by 3, move up by 3. Right? And I can move the whole thing up and down. Kind of hypnotic, actually. That's right. Oh, that's cool. Did you say this is like a carrot? Oh, like the carrots that have gone like on the crinkle. Yeah, no, but I know exactly what you're talking about. They come usually like frozen in a bag, right? And they're like, yeah. Oh, somebody's too good for frozen carrots in the corner. Sorry. Yeah. It makes them fun, and your kids will eat them, or they won't. Yeah. My kids, I periodically raid their rooms because they hide candy. So like I know that if they come to dinner and eat no dinner, that they both got like candy stowed in their room somewhere. And sure enough, I'll go like open like a couple drawers and there'll be like just bags of candy. And it's like they've gone to the corner store and bought loads of candy and hid it in their rooms. I eat it. What kind of question is that? It's like you guys think I was born yesterday. Come on. Hide candy from me. No, it doesn't work that way. And I eat it in front of them too. I want them to know. I am that parent. See? Okay. So when we do this, we are still, because we are outside of that sign, we are not taking the sign of +1. This affects the function on the whole. It is the y value that's going to change. So in the first one, we want to make it sine x +1. So this will be the original y value +1. The x values won't change. But they shouldn't. So go ahead and fill these in and graph them. Take a minute. Fill them in, graph them, and I'll walk around and say things like, yeah, keep going. Good job. Or, sorry, or focus, get off your phone. Or put the fidget spinner down, damn it. That's one of my grade 9s. So. Fidget spinners, they are fun. Yeah. Yeah, no, I actually think the super, and like just even, but like say for instance, like you hold it and like as you move it, like you feel it like tugging your hand and moving it. Like, it is really cool. Like, oh, it's kind of thing that I would do. I don't know if I'm doing it. Well, I guess you don't want to like, scratch your skin. It's also pretty tough. Yeah, that original diagram. Why do you? Why did I just do that? That's too great.
If I have one, I can use it all the time.
Are you bitter about fidget spinners and you're pretending like it's for something?
Like I'm like, that's a cool. Yeah, like even around it.
In my day, we stopped fidgeting because the teacher was scary.
Really?
Yeah.
I feel like I get
You were really good.
I'm not scared. I don't have that in my grade. The teacher used to
You're actually quite terrifying.
He used to lift the whole thing up, like seat and all. Like, yeah, I mean, I was like saying, like,
Wait,
quiet.
Wait, like with.
Yes.
But, you know,
He's like, oh,
James is going missing.
You in good shape.
There's
There's a reason I worked at the kitchen.
That's
That's a great way to get rid of it.
I was like.
He's feeding.
Can I get like a tomato any sort of like on a
I don't throw anything. I'm just saying, like, I'm all talk. Good. Then again, I used to actually do the string on the doorknob thing.
Yeah. You're on your own. Yeah, no. Like,
String on the doorknob.
Yeah, exactly. I don't know why.
It's great. It's quick. It's painless. It's fun. Like there's a scientific experimental element to it. All right, what do we get? G at X. What should happen to it? Are the X values going to change? No. So we should have 0, 90, 180 if we map this function, 270, and 360. But what's happening to the Y values? Yeah, they're all going up by how much? They're getting a raise by 1. So 0 will become 1 will become. Come on, team. Come on, let's get moving.
1 plus 1.
Okay, what about 0? It becomes -1 will become 0 is correct, and 0 will become 4 is incorrect. You're wrong. 1 is correct. Good. Okay, and so we should graph those. Okay, I can do this. I have faith in me. Oh, I've already failed. I thought I had faith in me. Turns out I didn't. It's not very good, but it'll do. That's actually what it says on my resume. He's not very good, but he'll do. What did you say? That is not what it says on my resume. That I'm a gross color? I think I have a lovely, lovely skin tone. It's very nice. If I picked up a what?
A crayon that said Joe was Orlando.
That would weird me out. No, that would. That would be a great prank to play on somebody. Just, yeah, like if you, there's potential there.
Makes me feel like you're getting short by putting the
That's wow. I had a guy, I used to manage a restaurant, and he had been late all the time, and then he really started to do well, and he was on time all the time, and I was proud of him, but I thought it'd be fun to play a prank on him. So I started every time he would come in, I would reprint the schedule and go to all the effort of reprinting like all the handwritten notes on it, like so-and-so changing so-and-so, and I would change his start time so that I'd made it so he either came in an hour late or he came in an hour early. And every time he came in, I'd be like, Lauren, what are you doing? You're supposed to be an hour early. He's like, no, I checked the schedule like 3 times, I'm sure. I'm like, well, why don't we go check the schedule together, Lauren? And he'd be an hour late, and then the next day I'd change it again, and this time he'd be an hour early that day, and I'd be like, Lauren, what are you doing? Like, you don't have to be here for 1 hour. And I was like gaslighting him, and it was fun.
Like snacks.
You were mean.
I stand by it. Yeah, no, that is a good old fashioned prank.
Yeah, there's no such thing.
He once came up behind me while I was talking to a table that was complaining. Yeah, and you know those like handshaker things you can get that like buzz people? He just put it on the back of my neck. So I was talking to a table and then just did like a and then he just kept walking. And they had a complaint. So imagine asking to see the manager, he comes out, and then in the middle of the conversation, like just full on spasms and like makes a sound. It was pretty awkward and pretty funny. I gave him full credit for that. But point being, he's not some innocent victim. You don't need to feel sorry for him. All right, what about H and X? What do we get? Yep, a half. Good. That is way too. Oh yeah. Any of those like comic type stores, like where you get like props and things like magic stores. Yeah. Okay, what happens to 2 or what happens to 1? The original 1 if we're subtracting half. I think we need to restart this thing. What happened to 0? Remember, we're going from the original function. So 0 minus half becomes negative 0.5. The next point should be, yeah, the point after that. Then negative 1.5, then, very good. I'm sorry, I wasn't trying to be negative. Okay. Okay. Oh, ketchup, relish, and now some mustard. Okay, I'm on it. Oh, but that was really bad. I can do better than that. How's that? Yeah, I feel good about that. Caleb, have we really hit the point where you're criticizing the imaginary condiments I put on non-existent hot dog? It sounds about like my day. All right, so there we go. Next time you go to like Costco and get a hot dog on the way out, you can think sinusoidal functions. Yeah, it is good. Yeah, but the amount of people is truly horrific sometimes. I got you. I'm live and well known for my athletic prowess. Oh, this is funny. Because she took my hand off with a high five today. Now she could laugh.
Nobody had a hard high five.
Listen, for my delicate hands. Very delicate on a flower. Did you hit a flower that hard?
Yes.
That's probably what you do. You probably go home and just find flowers and hit them. All right.
I get a lot. I feel like the dandelion.
My wife is a little OCD just by nature, and this year her new obsessive compulsion is the removal of dandelions from our yard. So she bought one of those, like, you know, the thing like you step and you twist and then you lift and the weed comes out. Yeah, thing's great, right? But this is like all she does now. I think she's gonna get like a stress, like a repeated motion stress, like one of those, like a muscle damage, because it's just all
What
she
if she
does.
gets like jacked from it? Like,
That'd be weird.
Why would that be weird?
She's probably already molested.
No, is she? No, I could take her. Yeah, I could take her. I'm gonna have to fight her tonight to see. Like, sorry, Brett. Oh,
I'm sorry.
like, but I'm just gonna make dinner. And then be like, oh, I totally took her. Look at that. That's great. It's totally a fair fight.
You're fine. You and your boom.
My wife would kick my ass. Like, first of all, despite all the comments, I'm a pacifist. I don't believe in violence. But second of all, my wife, like, probably isn't physically stronger than I am, but she's intense. I wouldn't want to get in a fight with her.
You'd like push her.
No, like I just don't think. I think she'd like play dead, so I turned around feeling bad, and then she'd like choke me with something. Like, yeah, she's coy. She's not that this takes much, but she's smarter than I am. Like, she'd win the psychological battle. Anyway. Yeah. Anyway, I don't see us getting in a fight, but if it happened, I think she'd win. I think it's unlikely. Like, we've been together.
Yes, you'll grow forward.
We've been together like roughly 15 years now. I think like if a big fight was coming, it would have happened. I think we're past our fighting prime.
Like Dave right here.
We are.
You saying she's gonna next time I run for something, she's gonna interfere in the election? All right. Well, anyway, I like it. Okay, so let's take a look. If you will note, the axis that divides this yellow one in the middle, where do we find it? Equals at negative 0.5. The axis that divides the green one, where do we find that? Right, so this line cuts that green one right in the middle. Where did we find that? Bueller, anyone? People still watch Ferris Bueller's Day Off? It's a great film. You know when Ben Stein, the teacher, is in there and he's teaching history and he's like, and this led to anyone, president, rhymes with Reagan, that's correct. And he believed in something that George Bush called anyone, rhymes with hoodoo economics. That's correct, voodoo economics. That's how I basically feel as a teacher with you guys every day. It doesn't feel good. Anyway, so where do we find this line? Yeah, y equals 1. So if you look, whatever that k value is, that's where the line that divides this sinusoidal function in the middle ends up living. And I think, because I was feeling kind. I didn't want to make you write it when I could just type it. Why have 10 people write it when I could do it once? That's what I thought. Let's be efficient. That's what I'm well known for, my efficiency. Well, at some point you have to learn something. Okay, here we're going to start talking about the flip side to this, the horizontal stretch and compress. And to stretch and compress horizontally, to change the input of the function, to change the x's, we have to make sure that we're making changes right up against the x. So this time, it's going to be sine 1/2 x. Does that make sense? We're changing the x's themselves. That makes sense? Now, what do we have to remember? X's themselves. What do we know about x? That cagey fellow. He lies. So if we remember, in this case, the y values aren't going to change. We're not changing the output. We're changing the input. So this is going to stay 0, 1, 0, -1 and 0. But what's going to change is the x value. And at this function, sine 2x, you would think that this 2 should mean that we do what to every x value? We would expect to take every x value and well, to me, I mean, that is what we're going to end up doing. But that's not intuitive. Intuitively, we think that we're doubling every x value, right? Sine 2x, you would think take every x and multiply it by 2. What we have to remember is that because we're taking the sine of 2 times x, we can think of that as looking at what the sine would be if x were half as big as it is. So x is going to be cut in half. So we get the x prime by dividing the original x in half. And I can prove it to you. If we go to Desmos and get rid of that k there, and we put a b in with the x, oh, for goodness sakes. If I make b2, intuitively we'd expect this thing to get stretched out twice as wide, and in fact, precisely the opposite happens. It gets compressed in. All the x values actually get cut in half. Why? Well, we remember that x always lies to us. It always does the opposite of what we expect. So we have to divide all the x's in half. So 0 will become, yeah, it stays 0. What about 90? Very good. What about 180? Yep. What about 270? I think so. That sounds right. Yep. Look at you. And 360? Very good. Now I'm going to do this with, what color? Maybe with nice purple. No. With a nice orange. I like that orange. People say orange or like orange. I feel like I say orange with an extra syllable compared to other people. Like orange. This is orange.
I don't even know anymore.
Yeah, sorry. Fair enough. That's a good answer. Well, this is going to be miserable, but I'm ready. Oh. Having fun now. I'm trying to get the next one in as well. What happens when we do h of x equals 1/2? Did I say a half? I think I did, yeah. Equals the sine of 1/2 x.
Are you sure?
Let's check. Oh, yep, I'm sure. Okay, whew, that was close. Ah. In the end, retrospect, poor color choicing. Right? The orange and the red, maybe more similar than is ideal. The green is nice. It stands out. It physically hurts you. I think that's a little type of wall. Thing. Okay. Let's see what I can fix this. Or I can't. One or the other. Hello. They did. I'm pretty pleased.
Oh, and one underneath too. Right on.
Yeah, they were speedy. It took them about one period and a little bit more. Is that better?
Mr. Putnam, are you still doing the time quiz tomorrow? Yeah, you are. Oh, bring an extra shirt. We tested it on Kristen during period 3 and it went all over like.
Oh, great.
It was lovely.
That's good. And say again your hair.
Yes.
Yeah, you are.
Whoever.
Yeah.
You're earthly one.
I'm glad you were.
I'm doing my best.
That's great.
See, the blue one with the orange dots gets cut, squished in half, so it's much smaller wavelengths. And then the green one, much wider, like that. It's my best I can do. I'm fine. Don't judge me. Okay. Okay. Well, then make your own. Make your own. The point being, the one that says 2x, you would expect to make it twice as wide. It doesn't. I actually make it half. Okay. By the way, as long as you understand it, it may be much more useful for you to not even fill this in, but to just make sure you can go into Desmos and understand that if I make this 0.5, it gets wider. In fact, 10 to 10 is too much. Let's go like negative 5 to 5. Right, so as B gets bigger, they actually get closer together. As it gets smaller, the opposite happens. Or the internet, just like that. It's also kind of hypnotic. I have to say, okay. Now, yes, absolutely. What happens to the period of any of these functions? What is the period of a standard sine wave? How long does it take to do one full cycle before it just starts repeating? What? Very good. Every 360 degrees, the thing repeats. So in this case, as we add this B value in, that's changing the 360, right? This blue one, where we made 2x, its period is now what? How long does it take to do one full cycle? 180. So that 360 has been divided by 2, cut in half, yeah. And here, where sine is 1/2 x, now instead of 360, now how long does it take to get a full period? 720, which is actually dividing by 0.5. Dividing by 0.5. That was something. So to find the new period, the base period is how long? 360. I don't know why this won't move. I want it to move. Oh, now it's moving. That's right. So the period will always equal 360 divided by whatever that B value is. 360 divided by the B value. This is probably the most important thing to understand when modeling things using a sinusoidal function, right? Because if you just use a sine wave, it assumes that that full cycle is going to take 360, right? So would we be able to use a sine wave just by itself to model the lunar cycle? No, because we said the lunar cycle takes 28 days, right? So we have to be able to change that period. So to model the moon's brightness using a sine wave, we'd have to use some b value that would let us get to 28. I'd probably do it in 2 steps. I'd divide it by 360 and then multiply it by 28. Right? The fraction of 28 over 360. So 360 over 28. And again, you're going to get some practice with that. All right, so we've stretched it up and down. We've moved it up and down. We've stretched it left and right. The last thing remaining is to... We just squeezed it. This squeezes to stretch and squeeze. The last thing left is translation left and right. Shift the whole thing. No, but that answer was adorable. Okay. So starting with the exact same. This time, we want to shift it first, x plus 180. X plus 180. What do we remember about x? It lies. So if this is sine x plus 180, how are the x values actually going to change? We're actually going to subtract 180 from it. It's always the opposite of what we expect. So this 0 is going to become what? Very good. 90 is going to become? Yep, nice and loud. Very good. 180 will become? 0. 270 will become? Very good. And 360 will become? Very good. So you can see it just shifts everything to the left. Do the y values change? No, we haven't done anything to change them. Okay, I'm going to pick my colors well this time. So when we do that, we get the transformation like the green one here, where we've moved the whole thing left by 90. Was I supposed to do that 180?
Yeah.
Well, that's unfortunate. Oh, sure I do. Think how much you learned in that process. Learned about math.
Actually, basically flipping it if you think about it.
Well, that's the interesting thing, is that these functions can mask themselves as other transformations, right? It looks like a flip, but in fact, it is a shift left by 180. Yeah, interestingly, you could make the exact same transformation using an a value of -1. Two different transformations, but the same output. Interesting, right? I find it interesting. It does kind of look like DNA, doesn't it? Did I say doesn't it?
Yeah.
Oh, God. It's unbearable. Oh, no, no. Doesn't mean I like folk. No. For me? No, I'm kidding. I like folk very much.
I know it's mutant.
And now it's mutant DNA. There we go. It looks like a wallpaper pattern from the 60s. My basement kind of looks like that. Not those colors, but similar pattern. Anyway, so there we go. So those are kind of the four only types of transformations we do in the sinusoidal function. And interestingly, you've picked up on a really interesting note about them, which is that some can mask as others. This green one is achieved by shifting the whole thing to the left. But just as easily, you could achieve that exact same transformation by flipping the whole thing. You could use an a value of -1. You get the same appearance, the same transformation. So the cool thing about sine functions is there's a lot of different ways to manipulate them. The starting value of the sine wave shifts. What number could I use here that wouldn't change it at all? What could I have shifted it by that would make the graph look exactly the same?
0.
Okay, yes, obviously 0.
1.
Let's take a look. If I get rid of b, but I add, we use h for this, right? If I put an h value here, and maybe I'll put an original function here too, so we can see the two and compare them. Okay, so these numbers are really small, but they do start to shift it. See how it starts to shift like that? What happens when I make it 360? It's the same. Why is it the same? Yeah, by one cycle. If I move it completely by one cycle, it ends up being the same. What if I move it by -360? It's the same. So if we move it by exactly the period, then it doesn't actually change at all. Does that make sense? I just want to make a note of that. If we shift by n times the period, where n is any integer. So if we move it by 360 or 720 or 1080 or anything like that, the function is unchanged. So in practical measure, now I sound like I'm trying out to be like the Russian villain in a bad 1980s film, but no, I really can't. No, I don't even know how that would sound. By any measure. No, yeah, no, not happening. Is there any reason to shift a sine function by more than 360? Would it ever make sense to shift it by like 2050? No, because you can always achieve your change within the period. Does that make sense? Because once you change it by more than 360, you're just repeating itself, right? So if I made this 750, it just repeats itself. Okay, shut up. There's something kind of mesmerizing about that. Now it looks like the screens you'd see on the background of like a Star Trek movie, where it's just like, it's supposed to look sciencey, so they just have like waves doing stuff. Okay, I'm gonna give you some homework, which I want you to do. Yeah. Okay, well, I work tonight too. No. Tonight I do some consulting. So tonight I'm actually going to do that. But I'm still gonna have to come home and prep lessons for tomorrow, so I have something to teach. I do. Until I get paid.
No, you don't have to
I'd somebody
do
have a
that.
copy of the textbook that I can steal.
No, actually, no.
In my locker.
Really?
No one has anything.
Nobody brought the textbook? What's wrong with you? Can I borrow this, please? Come on, hand it over.
Good afternoon, East Dale. Here's just another reminder. On Saturday, the weather's going to be great. We're going to have our car wash, our barbecue, and our bake sale fundraiser. Please see Mrs. Marshall in guidance to sign up if you'd like to volunteer and get some community hours. It's this Saturday, so please come on out and sign up for your volunteer
I'm
hours.
hoping.
Don't forget, ladies and gentlemen, bring in that Tootie Squad. If you want to put pie in teacher space, bring in that Tootie. That's right.
Looking at you, Orlando.
I don't mind getting pie in the face.
Put a pie in Tootie space, and here's Miss Scott.
Does it depend who puts the pie?
I do mind getting a pie in the face, but there is something about it only costing $2. It just feels a little.
The end is almost. Read your Toronto Blue Jays form and money. We need to know by Friday, that's this Friday at the latest, if you plan on attending the trip, giving the tickets away to another school.
309, number
So come and see me, Miss Cook,
309,
and let me know if you plan on coming.
Look at it. If you don't see it, we have to do it.
If a tree falls in the woods and nobody's there to hear it, did it still say make a sound?
No, that has nothing to do with it.
Yes.
It's kind of the same question.
Absolutely does. And
Yes. Yes, you can. And I will mark it, 32. 30, you owe me a test, yeah? Here, listen to me. I've got to go home and look after my daughter right now because she's sick, so I can't have you do it now. But tomorrow, I'm still well after school. Didn't get done by the end of tomorrow.